So let's take a look at some examples here. We're going to determine whether Rolle's theorem can be applied to the function on the interval. If it can, we're going to find the values of c in the interval where the derivative is 0. Okay, so we're always going to be doing a check to see that we can apply the theorem, and then if we can, we're going to go forward. All right. So here we have f of x is x squared minus 2x on 0, 2. All right, so I'm going to check that do we indeed have f of 0 equal to f of 2? All right, well, let's check. F of 0 would be 0 minus 0, which is 0. And f of 2 would be 4 minus 4, which is 0. So yes. Now they didn't have to equal 0 at both ends, it's just that they had to be the same value. All right, is f continuous on closed 0, 2? Well, let's take a look at the function. That's just a polynomial, all right? This function here is just a polynomial. It's continuous everywhere. And in fact, if I ask, is f differentiable on open 0, 2? Yes, has to be. It's a polynomial, so it's differentiable everywhere. All right, so this all means that Rolle's theorem applies. All right, so somewhere there is a value, at least one value of c, where the derivative is 0. So the question I'd be asking is, what is c? Now again, the theorem doesn't go this far. We're going to show and figure out that where that c is, just so you can see that it's true. But the theorem doesn't give us a way of doing this, but this function is simple enough that we can do it. So we can simply calculate the derivative of this function, which would be 2x minus 2. All right, and then we can then say, okay, if I want this derivative equal to 0, well, that's 2x equals 2, or x equals 1. And note that x equals 1, the derivative is 0, and 1 happens to be in our interval. So this means that the c value we were looking for is indeed 1. All right, on to the next. All right, f of x equals 3 minus the absolute value of x minus 3 on 0, 6. All right, so is f of 0 equal to f of 6? F of 0 would be 3 minus 3, 0. F of 6 would be 3 minus 3, so 0. So we do get that. All right. Is f continuous on 0, 6? Okay, well, let's think about this. What would this graph look like? It's an absolute value graph. So if we take a look, this would have been the absolute value of x shifted 3 to the right, and then flipped, and then added 3. So if you went through and did this, you should find that it basically looks like this, where that's 0, that's 6, and that's 3. All right, so but what we know is, sure, this is still continuous on that interval. And then let's ask if is f differentiable on open 0, 6. Oh, well, now we have a problem. Obviously, we have an issue there at 3. So no, not differentiable at x equals 3. All right, so the end result, Rolle's theorem does not apply. It can't make any statement about whether there is a place or there isn't a place where the derivative is 0. Again, in this particular one, there isn't any place where the derivative is 0, but the only thing we lost was the guarantee that there is such a point.